Hey guys, this is Liam DeStefano, and today we're going to be solving a few problems together. First, we're going to start with graph transformations. So it says to consider the exponential function f of x equals 2x. Sketch and describe the transformations for each of the following. So gx equals 2 to the negative x, hx equals negative 2 to the x, and then k of x equals negative 2 to the negative x. And then explain how each graph is related to the parent y equals 2x. So the parent is y equals 2x, as it just said, is increasing, and its horizontal asymptote is y equals 0. Its domain is negative infinity to infinity. Its range is 0 to infinity, and it is a parent function, as it's set up here in the description. So that's what y equal 2x looks like. And then down here we have gx equals 2 to the negative x. It is decreasing, and its horizontal asymptote is y equals 0. Its domain is negative infinity to infinity. Its range is 0 to infinity. Its reflection is over the y-axis. Its key point is 0 to 1. So really, the main difference between the parent function and this one is it just is flipped around. So as you see here, it's going up for the parent function y equals 2x. Down here, it's going down, it's decreasing. And like I said, it just switched around. So just imagine flipping that around quick and mirroring it. Okay, next we have hx equals negative 2 to the x. It is decreasing, and its horizontal asymptote is y equals 0. Its domain is negative infinity to infinity. Its range is negative infinity to 0. Its reflection is over the x-axis, and its key point is 0 to negative 1. So for this one, the main similarity, it pretty much has the same path, but just flipped upside down. And lastly, we have kx equals negative 2 to the negative x. It's increasing, and its asymptote is y equals 0. Its domain is negative infinity to infinity. Its range is negative infinity to 0. Its reflection is both axis, so that axis x and the y, its reflection is in both axes, so the x and the y axis. Its key point is 0, negative 1, comma negative 1. And that is, and the main similarity between it obviously is its path. It's just, imagine flipping it upside down and then rotating it the opposite direction. Alright, on to problem 2. Solving algebraically and graphically. Solve the equation both algebraically and by showing on a graph. So e to the 3 minus 2x equals 4. And we have to solve algebraically for x. Sketch the graphs of y equals e to the 3 minus 2x and y equals 4. Show the intersection point. Explain how the algebraic and graphical solutions agree. So the algebraic solution down here is ln times e to the 3 minus 2x equals ln 4. Okay, we use the rule e to a, so a is going to be, we're going to replace a with 3 minus 2x, which will equal ln 4. Go down, switch some stuff around, so negative 2x, that 2x here, that negative 2x is going to be put here on the left side of ln 4, or negative, so we're going to take 3 and make it a negative and put it on the right side of ln 4 and keep negative 2x where it is. And then we're going to make this a fraction and put 3 up top minus ln 4 and 2 on the bottom. So ln 4 in just its decimal form is going to be 1.3863, and we're going to keep that as its like basic form. So that will be, so now it will be 3 minus 1.3863 over 2, which will equal 0.8069. Okay, that is the algebraic solution. The graphical solution of this would be y equals e to the third minus 2x decreasing, and y equals 4, which is the horizontal line. They intersect at x comma y, which is equal to 0.8069. Why? So why did they agree? They agree because the algebra form gave x equals 0.8069, and the graph meets exactly at x equals 0.8069 and y equals 4, and the graph is down here. Okay, on to problem 3. Inverse relationships. Let f of x equals e to the x plus 4 plus 1. Okay, so we need to find its inverse function, f minus 1, f to the negative 1 of x, and then sketch both graphs on the same axis, including the line y equals x. Okay, so we'll explain why logarithmic functions are reflections of exponential functions across the y equals x axis. So we need to first swap x and y, so it would look like y equals e to the x plus 4 plus 1. So that we'll switch out the x, and we'll switch out x here and make that a y, so it'll look like this to the right, y equals e to y plus 4 plus 1. So that's what it'll look like after we swap some things around. We need to subtract 1, so it'll be x minus 1 equals e to y plus 4. Okay, and then we'll take the natural log, so ln times x minus 1 equals y plus 4. And we'll go down here and solve for y, and y will equal ln x minus 1 minus 4. After that, it'll be f to the negative 1 x equals ln x minus 1 negative 4. So we found its inverse function here. So f to the negative 1 equals ln x minus 1 minus 4. That's its inverse function. So the main difference between these is blue shifted left 4 and up 1. Green shifted right 1 and down 4. So the inverse function is the green, and then the function that we were originally using is the blue. Okay, down here, the reason why logs are reflections of exponents is because they are inverse functions. So that means that they undo or reverse each other, like an Uno, almost like an Uno reverse card, if you think of it like that. But we would switch the values. For example, if we had x and y as values, then we would just flip whatever the values were around. So x and y would equal y and x. This makes both graphs mirror images of each other. Okay, now we're on to the last problem. Problem 4, putting it all together. So consider the function f of x equals negative 3 times ln to x minus 2. So identify the domain, vertical asymptote, and intercepts. Describe the transformations from the parent y equals ln x. Sketch the graph and show how each transformation is applied. Okay, and explain how this function illustrates horizontal shift, vertical shift, reflection across the x-axis, and the inverse relationship to an exponential function. Okay, so the domain of this is 2 comma infinity. The vertical asymptote is x equals 2. X-intercept is 3 comma 0. The y-intercept is 2 comma infinity. The horizontal shift it shifts horizontally to the right, so y equals ln times x minus 2. It vertically stretches by 3, so y equals 3 natural log x times x minus 2. And then its reflection across the x-axis, y equals negative 3 natural log times x minus 2. You can see that in the graph down below. This is just added for extra. Its vertical asymptote is x equals 2. X-intercept is equal to 3, 0. Down here, we have the inverse relationship to an exponential function. So the inverse of fx equals negative 3 natural log times x minus 2 is the exponential function f to negative 1 times x equals 2 plus e to negative x over 3. And we're just restating down below, f of x equals negative 3 natural log times x minus 2 is the logarithmic, and then f minus 1 times x equals 2 plus e to negative x over 3 is the exponential, and then its reflection across the line y equals x, and you can see that in this graph below. Thank you guys for listening, and I'll see you next time.